We can brute force a buffer by combining a weak ester base with its conjugate salt, or we had a couple other ways we discussed earlier, which is excess weak base with a strong acid or excess weak acid with a strong base. Right now we're going to look at this option, excess weak base with our strong acid. So in this case we're going to be given the 3 molar HCl and then solid sodium formate, and I want to glance very quickly at the reaction taking place, and that is our HCl plus our formate ion making formic acid. So let's try this. And I'll write this and then I'll write it simplified like a net ionic equation. But we're starting out with NaHCO2 plus our HCl. And that's giving us HCO2H plus NaCl. Now the catch is that NaCl is a spectator because the Na is a spectator because the Cl is a spectator. So what I'm going to write this as is just HCO2 minus plus H plus goes to HCO2H. So this is the actual equation we're working with in terms of stoichiometry, and this is the basis for us using this to make this. Because starting out, so we're just going to do some stoich here. Starting out, I don't have any of this. In fact, all of this that I need has to come from here by reacting with this. So in the end, based on our ratio, I know I need 2.75 moles of that HCO2H from our previous calculation. In fact, it would be good if I wrote that down. We have 2.75 moles of the HA and 0.5 moles of the A minus. So whatever this change is, and then as a product, so in the end, we're starting with 0. Somehow we need to go up by 2.75 so that we can end up at 2.75. And the way stoichiometry works is I need to produce this from this by reacting with this. So I need to start out with 2.75 moles of that so that I can lose 2.75 moles of that and end up with 0 there. And by some quick math, in the end, I need 0.5 moles of that A minus. So if the change is minus 2.75, we're going to end up with 5 plus 2.75, which is 3.25. All right, so in short, that number right there and that number right there are what I need from these things. In fact, I'll try and color code that a little bit. I need 3.25 moles from this, and I need, lost all my, there we go, and I need 2.75 moles from that. And the basic setup, once we know those amounts, is going to be very similar to what we saw in the previous example, or option 1, as I may have called it. So let's look at this. I need 3.25 moles of HCO2 minus from NaHCO2. We know that moles is mass over molar mass. In this case, to get my mass then, it's going to be my moles times the molar mass. All right, and in this case that's 3.25 times our 68 grams per mole. And again, I'm stepping on our sig figs a little bit, but we should end up with 221 grams. And that is the first part of our recipe to get that 3.25 moles of HCO2, NaHCO2. All right, that is the yellow highlighter. For the acid, we're working with 3 molar HCl, and we know that molarity, moles over volume in liters, we need 2.75 moles of our acid, and so our volume in liters is going to be the moles over the molarity, and that's 2.75 over 3.00 moles per liter. And we end up there with a number of 917 liters of 3 molar HCl. And that is the other half of our recipe, what I highlighted in purple up top. So now we just need to write instructions to prepare it. Again, we're going to declare that we need 1.5 liters, not for any reason other than I needed a volume, and the volume doesn't matter. So let's write our instructions. Last time I wrote them in fancy green, so I'll write them in fancy green again. We're going to dissolve our 221 grams of NaHCO3 in the 917 milliliters of 3 molar HCl in a 1.5 liter volumetric flask, and then we're going to dilute to 1.5 liters total. So we'll say mix 221 grams of sodium formate NaHCO2, good, with 917 milliliters of 3.00 molar HCl. Those are our ingredients there. And again, you could make any amount you want. In this particular case, you couldn't make less than 917 milliliters. In fact, when you take this and this, number one, it may not dissolve in there, but number two, that volume is going to change pretty drastically. That's a bunch, so it may even be a fair bit over a liter. There's no good way to calculate that, but that's why I chose 1.5 liters specifically. Right, and that should be distilled or deionized water or whatever. With my infinite stubbornness in mind, I'm going to try and squeeze option number 3 on this page. Just like we had the option of strong acid with the weak conjugate, we can also do weak acid in excess with strong base. So we'll call this option number 3, and we're going to say given 3.00 molar NaOH this time, and 6 molar formic acid. Now, just like up here we had a basic stoichiometric situation, in this case we've got our base NaOH and our HCO2H, and I'm just going to ignore the Na right off the bat. We'll say we have our HCO2H with the hydroxide ion, and that's going to give us water, and the HCO2 minus. And that gives us our conjugate pair. The difference here is, for my solid, or I don't have solid rather, so let's try a different thing here. For my acid right here, the 6 molar acid is what's going to give me that right there, and then the sodium hydroxide is what's going to give me that number right there. And we're going to set up the same basic type of stoichiometry, knowing this number and this number. And I realized it was kind of hand-wavy up here. I'll do it hand-wavy again, but I'll see if I can go back and slow it down. We're going to do stoichiometry, and I know in the end I need to have these amounts. So I need 2.75 moles, and I need 0.5 moles. Right? And if we started with 0, it has to have gone up by 0.5. And if this went up by 0.5, because of the 1-to-1 stoich, this had to have gone down by 0.5. And in order for this change to have taken place, I need 0.5, lose 0.5, end up 0, and I just need to add them here, and then I get this 3.25 moles of that I need. And let's get those numbers to match with our highlighted numbers. The HCO2H is 3.25, and the hydroxide is going to be 0.5, and those are molar amounts. So we just need to come up with them. Another way to think about it is, and I'll write this off to the side, much as I begrudge that space right now, we know for up here with our A minus over our HA, all of this A minus comes from the HA in this particular situation. So we need this number plus this number to be the amount of our acid we start with, as opposed to this one where we had this, and it was from this right here. So we had to start with all of this and turn it into this much. So our starting amount had to be this number plus this number right here, and our starting amount had to be this number plus this number right here. You may like that explanation better, though it was kind of a mess, or you can just look at how the stoichiometry worked out there. Now we're going to do this exact same type of breakdown. We have a molarity, we have a volume, and so, or sorry, we have a molarity in moles, we can get a volume. Molarity for our NaOH, 0.5 moles NaOH. So we know molarity, moles over volume in liters. Our volume is going to be our moles over our molarity, and that is 0.5 over 3. And so that ends up being 0.167 liters of 3 molar. Alright, that is part of our recipe, 167 milliliters of our base. And just so we have room to write our instructions, I'm going to continue this calculation over there. We know molarity is your moles over your volume in liters. Your volume in liters should be your moles over your molarity. In this case, we need 3.25 moles, and we're getting it from 6.00 moles per liter. And that is 0.542 or 6 molar HCO2H. And that is the other half of our ingredients list for our recipe, and that's our red highlighter. So let's write the instructions then. If I can find our exciting marker. So here are our instructions. Going to look very similar. We're going to mix, only this time it's a solution and a solution, 167 milliliters of 3.00 molar NaOH and 542 of 6 molar formic acid. And again, that volume could be anything. Now you've got them in a container, dilute to a total volume. And that is option number 3 for preparing this buffer. And I realize that's a bunch of stuff, so maybe I'll add in a summary in a minute.